There it is. All right. Let me actually see if I can make this a little bit bigger. About that. How about that? Is that better? Yes, it is. All right. So a letter is picked at random from the letters of the word random. So let me just write that down here. This is the word random, right? This is the word. Now, we need to calculate the probability that it is a letter from the word maths. Maths. Like that? Yes, maths. All right. As usual, we begin with any type of probability, the probability of the event. Again, this is the way you write actual mathematics with proper notation. P is for probability, and between the parentheses, we're going to write down event, the type of the event that we need to use. Now, in this case, the event is so incredibly long, probability that the letter is from maths. It is so long that I'm just going to write the E for event. In other cases, I'm going to write different other things in the space for the events, all right? So here, what is the probability of the event? All right, so we know the probability will be the success of the cases over the total amount of the cases that we have. S over T, the success over the total possibilities. Now, what are the total possibilities? Again, all the possibilities that we have when we choose at random the letters. That is the question, right? We're going to choose at random one letter from the word random. So if we choose at random, how many possibilities do we have? Okay, we can choose the R or the A or the N, maybe the D or the O, or maybe the M. That makes it that we have 1, 2, 3, 4, 5, 6. 6 possibilities. That is the total right there. We have 6 possibilities because the word random contains 6 words. 6 letters, sorry. All right, so the total possibilities is 6. Now, I like to begin by filling in the total first, the denominator, because that way I can calculate how many of those are successful. Again, I like to do it that way. You can just begin with the success if that is something you prefer. From here, what are the success? All right, the success is the event in which we actually picked a word that is also from the word maths. For example, if we pick the word R at random, right? Notice how R is not successful. It's not a successful event. Out of these 6 letters, picking an R does not give us success because R does not belong to the word maths. Remember, that is the question, right? We need to calculate the probability that the letter we choose is a letter from the word maths. R is not here. So R is not a successful possibility. We don't calculate it. We don't count it. But what are the words that are actually successful? All right. A is successful because it is right here, maths. So right there, we have one possibility of a letter that is successful. How about N? N is not, doesn't appear in maths. D is not either. O, no, and M. M is, which means that we have 2 possibilities out of the 6 in which we can find success. 2 over 6. Is this a proper way of living the probability? No. We need to simplify whenever we can. 2 over 6 is the same as 1 over 3. These will be the right answer. Now, a couple of minutes ago, one of the students asked me, teacher, should I leave the answer like this or can I just leave it as a fraction, as a decimal or as a percentage? You can choose any of the 3. Just make sure you round perfectly, properly. You always are going to round to 3 significant figures unless the exercise is going to tell us something different. So this is a good number. Another possibility will be, and again, this is equal because this is the real answer. But now we're going to use the sign for round. This is equal to 1/3, but round to 0.333. three significant figures. Perfect. This is also a second possibility for a good answer. How about a third? The probability, the percentage, sorry, sign. Again, we can round that to 33.3%. Don't forget about the percentage sign. And now this is also a good answer. That is, guys, how we do this type of exercises. All right. All right. All right. All right. All right. That was question number one. That was question number one. Now, that is one of the easiest. That is one of the easiest. Let me just move around here so that you can see the answer. There we go. That is one of the easiest. I want to move into something a little bit more interesting. Huh? How about we do number 4 already? Number 4 looks to be a little bit more interesting. All right. Guys, did you finish copying this? Can I erase? Write something in the chat, please. Guys? There, thank you. All right. All right, I'm going to erase this then. Beautiful. All right. That was number 1. Let's jump into number 4. Guys, I like this configuration because like this, I can see myself and I also can see the book. But if you don't like it that way, you would prefer to have the book bigger, just let me know, right? I can increase that in, just don't have me, or I can change between book and then board and something like that, all right? Just let me know. All right, we go with question number 4. It says, a personal identification number, PIN, consists of 4 digits. All right. Consider the PIN 0005 equal to the number 5, and etc. All right. So we have PIN numbers, right? Those are personal identification number, identification number, well, whatever numbers, right? Now, we're going to find the probability that the PIN is equal to 0000. That is the first part, right? A. I'm going to write it here. So we're finding the probability that the PIN is equal to 0000. Look at that. This is what I mean. This is what I meant in the previous exercise about writing in the parentheses the proper event. This is what you do. In the previous event, the event was so long that I just write down the word E for event. But in this one, the event is not so long, right? We can just write it. This is the idea. We're finding the probability that PIN equals 0000. This is proper mathematics. This is how you guys should write things. All right, let's continue. So let's think about the total. Let's think about the total. All right. So let's say these are the possibilities for our PIN. We have 4 digits. So I'm going to do 4 little spaces. The 4th one is not appearing. So I'm just going to do it here. Better. All right. So we have 4 spaces for the PIN, right? PIN, not PIN. There. We have 4 spaces for the PIN. Now, how many numbers can appear on each space? There. How many numbers can appear on each space? Well, how many numbers do we have? Because in here we can have from 0 all the way to 9, right? That is what it says in the example. One PIN can be the number 0005. 0005. What that makes me think is that these are the possibilities from 0 to 9, right? Now, how many digits are from 0 to 9? Don't say 9. Just count them. 0, 1, 2. Did you see what I did? 0, 1, 2, 3, 4. 5 already, right? 5, 6, 7, 8, 9. So we have 10 possibilities. Did you see? We have 10 digits from 0 to 9. So we have 10 possibilities here. Right there. Those are our possibilities. We have 10 possibilities. We can have the number 0 or the number 1, right? If you have the number 1, then these digits will be 1,000 something. If you have the number 2, then this will be 2,000 something. I think you get the idea, right? Cool. Let's think about the second one. How many possibilities do we have in the second square? Again, how many digits do we have for the second square? Well, we can do this from 0 to 9 again. We can just put any digit that we want. So the amount of possibilities is again 10. That is the amount of possibilities, right? Oy. Okay. If we continue doing this, then we have 10 possibilities in each of the squares. To count how many combinations is this, all we have to do is just multiply them. This will give us a total of 10,000 possibilities. That right there is our total. 10,000 possibilities. All right. Another way of looking at this is by thinking, all right, so we know one digit or one PIN number is this one, 0000. One person can have that PIN number, 0000. Okay? And the combinations go from this one all the way to the maximum possibility, which is 9999. 9,999. That is the last PIN number. PIN, just PIN, not PIN number, because that would be redundant, right? That would be the last PIN. This is the first PIN, and this is the last PIN. So how many pins do we have from this one to this one? Well, we have 10,000, right? 9,099, 9,999, plus this one. So we have 10,000. That is the total possibilities. Right there, we just found our total. Okay, beautiful. Now that we have our total, how many of those 10,000 pins are successful? Well, it depends on the event. The event is just this one. This is the only one that is going to be successful. 0000. This is the only one that is going to be successful, which means the probability is 1 over 10,000. And that is it. 1 over 10,000. Beautiful. All right, let's continue with the second one. How about B? What is the question? Find the probability that the PIN is less than 8,000 and more than 7,900. Okay, so this is what we're looking for. Probability that PIN is less than 8,000, but it is also more than 7,900. Again, guys, get the hang, get the custom of writing probabilities this way. This is proper notation in mathematics. Get the hang of it. Try to write it as usual as you can. Don't just jump into the answer, right? When we get to the next year in November, when you guys actually take the examination, 1 mark will be for the real answer. That is 1 mark. But sometimes the questions have 2 marks. 1 for the answer and another 1 for your notation. So if you did not write this in the proper way, you are missing 1 simple mark. The best way to get good at this is by doing it. Having mistake and asking, teacher, did I did this correct or not? And I'll tell you. All right, this looks like a 4. I just realized, so let me do it as a 9. Better. All right. So what is that probability? All right. So we know the total already. Again, pins are 10,000. That is the amount of pins. That is the total. We already calculated, again, by doing combinations and by just logic. 10,000 possibilities. But how many of those are successful? Well, the successful are the ones that are between 8,000 and 7,900, right? So just 100, right? Just 100. Find the less than, So, sorry. So just 100. It seems like that. It looks like this is just 100. It looks like that. But we need to make sure. Why don't we count them? How many numbers are from 7,900 to 800? How many numbers? Okay, so 901, 902, 903, 4, 5. I'm going to spend a lot of time here, right? But again, the first number will be 7,901, 7,902, 7,903. I can continue this, and as we can see, these are the values, 1, 2, 3. And if I just continue with this, I'm going to get until the point where this is 7,998, 7,999, right? If I continue, this is going to happen. So we have 1 possibility, 2 possibilities, 3 possibilities, 98 possibilities, 99 possibilities. Do I count the 8,000 as a successful possibility or not? Write it in the chat, guys. What do you guys think? Do I count the 8,000 as a successful possibility? Yes or no? All right, thank you, guys. Some of you are actually writing. Thank you. Beautiful. Thank you. You are correct. I do not count the 8,000. Why? Look at this. Simply from the notation, I have the lower less than. I have the less than 8,000. It doesn't say less than or equal. So 8,000 cannot be a possibility because it's not equal. I cannot count the 8,000. Look at the example. Look at the question. Sorry. Less than 8,000. It doesn't say less than or equal. I cannot count the 8,000, which is exactly why I didn't begin from 7,900. I begin with this one, 7,901. This is a good possibility. This one, 900, is not a good possibility. The same reason. This is more than, nor not more than or equal. So how many possibilities do we have here? Again, this is the first number that is successful. This is the second, the third, so on. And then the 98th possibility and the 99th possibility. So we only have 99 numbers. We don't have 100. If we do the subtraction, we did 100. But that is a mistake. This is something we need to analyze. 100 is not the success. The success is 99. All right. Which of these are we going to select? Do we leave this as a fraction or do we change it to a decimal? Up to you. Do we leave this one as a fraction or do we change it as a decimal? Up to you. Now, I prefer to not work more than I have to. That's what I prefer. So I think this is a good answer, and also this is a good answer. That is point number 4 for you guys. All right. At the beginning, I'm sure some of you read the point number 4 and just said, what? What do I have to do here? What? But it is that simple. It is pretty simple. All right, guys. Unless you guys have any more questions, I'm just going to continue with the next exercises. Anybody has a question? In the chat, please. Anybody? Okay, I see a bunch of no's. Okay, looks like no more questions. Beautiful. Let's continue with the next ones then. Exercise 7B. For these exercises, I am going to have to use my my screen, right? Because otherwise, I will have to copy these tables, and I don't have the time for that, right? All right. So let's begin with the first one. Let's do point number 1. Try to answer these 3 questions. And then from there, we can continue with one that is maybe a little bit more interesting. I don't know, maybe number 4 looks interesting. Or maybe one of these, right? In the experiment, or maybe one of these as well. It depends on what you guys want. Man, I cannot speak today. All right, let's do number 1. This is the question. All right. A survey was carried out in a small city. A survey was carried out in a small city center street. Whoosh. One Saturday afternoon. Shoppers were asked about how they traveled that day. The results are shown in the next table, in the following table. All right, so by car, these are the results, right? By car, we have 40 people that were male, and we also have 33 people that were female, right? So if I ask you here, if I ask you, guys, how many people in total, for totals, total, how many people use the car? Well, the total of cars will have to be the male plus the female. Female. Sorry about my writing, guys. I'm using the mouse to do this, and it is really hard. Sorry, guys. So that is the total, right? 40 people use the car, but those were male, and 33 people also use the car, but those were female. So the total amount of people that use the car is 40 plus 33, so 73, right? We can find those totals like that. That is something we can do. All right. We can also do the same for bus and for food, and by foot, right? So let me write the totals in here. This is 73. The total for bus will be 59 plus 49 plus 41. This is 100, right? Right? 10. And then this one, how many people walk to the mall? Small city center. To the city center. How many people walk? Thank you. 50. No.
66.
66. Thank you. All right. 66. Thank you, guys. Beautiful. I appreciate it. Thank you. Now, I like to write this. Look, I haven't even read the question. I don't know what the questions are, but this is something I like to do because it lets me try to understand the question. Once I know the answer, once I know the context of the question, then I can continue with the rest of the questions, right? All right. So those are the totals. But we can also ask about this. What is the total males? Huh? Because look, 40 people are male, but in car. But also 59 people are male, but on bus. And also 37 are male, but they walk by foot. They walk to the city center, right? They walk. So this is a different total that we can calculate. This will be the amount for car plus the amount for bus plus the amount for foot by foot, right? The total in this case will be 40 plus 59 plus 37. Can anybody give me the answer, please?
Creo que es 36.
36? Is that correct? All right, let's see.
Más.
31, 8, 9, and 4. Yes. Beautiful. How about for female? What is the total here? 1, 3, 6, 7. Beautiful. Excellent, guys. All right. Those are the totals. Now, from here, now we can start thinking about the questions. All right. Let's jump into question number 1. The first one. A. Find the probability that this chopper traveled by car. So one chopper was randomly selected. Remember, these are people shopping things, right? These are shoppers, right? So we're gonna select one person out of all of these. By the way, what is the amount in total, right? So the amount of male plus the amount of female. So this is 239, right? And look at this. Look how beautiful it is. If we were to add 79 plus 100, it should give us also 239. Not only like this, 100 this. Not only, doesn't matter what way you choose to do the addition. It should give you the same. It should. And it does in this case. Look at that. It does. Look at that. How beautiful is this? All right. So let's answer question A first. For A, let me write it here. A. So we're talking about the probability that the chopper that we choose at random was traveling by car. So this is the probability that this is the event that we're doing. Probability of car. That is the one we're doing. Remember, get the hang of writing with proper math notation, guys. In this case, this is proper math notation. So what is that probability? All right. We're going to have to calculate the total and then the success. So one chopper was randomly selected. That means the total of the amount of choppers are 239. Okay, that is the amount of people that were that day shopping things, right? 239. But how many of those actually use the car? Well, this one. Right? These are the people who use the car, the 73. So there we go, 73 over 239. There it is. That's it. Let's go with question B. One male shopper was randomly selected. Oh, look at that. That changes a lot of things. That changes a lot of things. All right, I'll explain that later. Find the probability that this male shopper travel on foot. So this is what we're looking for. We're looking the probability that we are going to select by foot, right? But only male. Foot only male. There we go. Man, it is really hard for me to write using this mouse. Sorry, guys. It is really hard for me to write using the mouse. Only. There we go. Foot only male. Why am I doing this difference here? Look at this. We are now not choosing one chopper at random. No, we are choosing one male chopper. So the total is not 239 now. It is not. Now the total is the amount of male because we are choosing only from males. So now the total is 136. That is the total now. That is what says here in the question. One male chopper was randomly selected. So we are not gonna count these 103 people that were the female. These ones, we don't care about those. These are not male. Those does not count. Those don't count for our total. Only these ones count. 136. All right. Now, out of those 136 male, sorry. How many of those travel on foot? Well, foot is this, right? 37. That's it. Out of the 136, only 37 use their feet or foot, right? Now let me write it here. 37. That's it. That's question number B for you. All right. Now, I'm going to make a quick parenthesis here. Hopefully you guys write this down. Whenever this happens, the total is now changed. That is a condition. In this case, this is this is the condition here. We are selecting from male choppers. Only male. So that is the condition. This is called a conditional probability. Let me write it here. Conditional probability. Takes a lot of time. Sorry, probability. There we go. Takes a lot of time, right? Whenever the total amount of people changes because they are giving us a condition, that is called the conditional probability, right? Conditional probabilities are written like this. probability of an event given that another event happened. You may read this as 1 over b. So let me change this line like this. Better now. The probability that one event happens given that the other already happens. In this case, the condition again, condition, there we go. In this case, the condition is B, the one that goes after this one. So we can change here, to be more precise, we can change our event in here to use proper math notation. What we can do here is find the probability that we go on foot, right? So that is going to be our first part, foot. Given that, that is our condition. So we put the little line here showing that this is now a conditional probability. And now we write down what is the condition. The condition was male. This is proper mathematical notation, guys. We are finding the probability that the person we choose goes by foot, given that that person was a male. This is perfect mathematical notation. All right. Let's go for question C now. Let me erase this, and this. All right. Question C. Again, we have the same condition, right? Look at this. Question B and C are under the same condition. So we know also that question C is a conditional probability, right? And we know the condition is male. That is what we know so far. Well, let's continue with the question. One male shopper was randomly selected. 1,300 shoppers visit the town in 1 week. Ah, look at that. Doesn't really matter now. Estimate the number of shoppers who travel by bus. It doesn't really matter, right? This male thingy was only for B. Number C is expected value. It's expected value. So we don't care about this probability here. All right, how do we calculate expected values? It's very simple, right? The expected value, again, this is proper mathematical notation. You write it like this. Expected value. This is how you write it. The expected value this is how you calculate it now. The probability of the event. What event? Well, it depends on the expected value that we're finding, right? Times the repetitions. This is how you calculate it, right? So the expected value for this question, for question number C, let me be a little bit more organized here. For question C, we are finding the expected value. And how do we know? Look at this. Estimate the number of shoppers who travel by bus. This is an estimation. It says right there. We're going to estimate, right? So we know that the repetitions are 1,300. That is what it says there. 1,300 shoppers visit the town in 1 week. And what is the probability of going by bus? That is the probability. So we know here. The probability of bus, that will be our expected value, right? Times the repetitions. And the repetitions are 1,300. All right? So again, look at this. Expected values. So whenever the question asks you to estimate a total amount, that is an expected value. And expected values includes a probability. So we have to calculate the probability here. What is the probability of going by bus? All right. It doesn't say anything else, right? So the total here is 2,039. So let me write it here. The total here is 2,039. Those are the total amount of people in our chart. How many of those were by bus? The total for bus is 100. So this is the probability of one person being chosen at random. That person took the bus. This is just the probability, right?
Profe.
What again? Yes.
Espera, es que me confundí ahí porque los 1300 no sería el valor total.
Paul, te cortaste y no te escuché. ¿Me repites, porfa? ¿Aló?
Que me confundí un poquito porque, o sea, el 1300 no es el valor total de las personas. Uy,
No,
profe, ¿no me
vea.
escucha?
Sí, te escucho perfectamente. No, lo hago en español,
Profe.
listo, no te preocupes. Mira, lo hago en español. Ponle cuidado. Mira,
Ah, bueno.
1300 es el total de personas que fueron ese día. Muy bien. 1300 es el total de gente que fue ese día. ¿Listo? Eso es cierto. Eso es cierto. Muy bien. Ahora, mira cómo la pregunta nos dice que estimemos un número, ¿sí? Entonces, cuando uno lo mira de esta manera, 1300 personas, si tenemos una probabilidad individual, ya me borro aquí, la probabilidad individual es esta. Y aplicamos esa probabilidad a cada una de las 1300 personas que están en total ese día, pues esas 1300 son las repeticiones, porque estoy haciendo una probabilidad 1300 veces. Mejor dicho, de estas 1300 en total que fueron ese día, ¿cuántas esperaría uno que fueran en bus? Pues es la probabilidad del bus por las 1300.
Listo, profe, listo.
¿Mejor?
Ya entendí.
¿Mejor, sí o no?
Sí, profe, ya.
Listo, papá.
Sí, señor, muchas gracias.
No a ti, papá. Muchachos, si tienen dudas, mis niños me preguntan, ¿listo? All right, let's continue. So in this case, this is the probability, right? This is the probability right here. 100 over 239. That is the probability, the individual probability of a person taking the bus, right? But we know that there were exactly 1,300 people that day, which means we need to do the multiplication. Guys, can you help me with this, please? $100 over 239 times 1,300. Anybody? Thank you.
Como 543.
Again, what?
543.
For 543? Is that it?
Punto 9, pero entonces no sé.
0.9. All right. Let's talk about the 0.9.
Sí, señor.
Thank you, brother. Is that only 0.9 or do we have more decimals?
Un 3.
9.3?
Sí.
More decimals?
Sí, otro 3 y un 0.
All right, so leave it like that. Let's leave it like that. Beautiful. All right, so this will be the answer, right? Now, do we round this? And if we decide to round this, by how much? Do we leave it as 543 or 544?
543.
43, right? So you're saying this, right? Just this. Just round this. So let me do the sign for round. You're saying let's round this to 543, right? Beautiful. All right, so let's talk about that for a second. All right, guys. So what Paul is saying is something that is really interesting because in reality, you cannot have 0.933 of a person. You cannot. Which means that this is a good example of rounding down, even though the rules of rounding are telling us to round this up, right? The rules of rounding are telling us to round this to 544 because we have a 0.9, right? So we need to move this up. But we cannot have a little bit of a person. We cannot. So this is a good example. In this case, we should round down. But you know what? It doesn't matter. In this case, we should not round. We shouldn't. Expected values are estimations, are not something that is real. Expected values are something that we calculate. We think this is the possible amount. This is a good answer just as it is. Now, we only round this if the question itself is telling us to round this. Sometimes that happens. In the question, sometimes the book or I don't know, the exam tell us to round the answer to the, I don't know, to the closest integer or something like that. Okay, in that case, then we round. But in this case, expected values, we are not supposed to round. We just leave it like that. Expected values are not expected to be rounded. All right, guys? This is a good answer as it is. All right, guys, that is question number 1 for you, A, B, and C. All right. Now, we can jump into another one, but given that we only have, 18 minutes, I don't think we're going to have a lot of time to do a lot of these. Remember, you don't have to do this, right? The class finishes at 12:30, so you don't have to do any of these. But if you want to practice, that's up to you. So we don't have to do all of this. We don't have to. That being said, guys, what exercise do you want me to do next? Write it in the chat, please. Don't just choose any. No. Read the exercises. If you think there is one you can do yourself, then don't ask me, because come on, you can do it. Ask me for one that you think is hard or you don't really understand the question. And that is the exercise you tell me in the chat, all right? Go ahead and do that, guys, please. This one is good. This one is also good. These two are really, really good. These two are really, really, really good. This one is really fun. Which one, guys? What exercise do we do? Nobody? Lau Avila says, we can do 2 or maybe we can do 5. Okay, if you're letting me choose, I'm going to do 5. Because I think there is something really interesting that not a lot of people can see if we do number 5. Majo Gutierrez is saying to do number 5. All right, Majo. Okay. Nobody else? So far, this is the winner. So far, this is the one we're going to do. Nobody else? Okay, then. Let's jump into point number 5. All right. Let's take a look at that question. Number 5. A large jar contains 347 marbles. So those are little balls, right? Marbles. Those are just little balls. 125 of which are red. So some of these are red and some of those are not red. Okay. A marble is chosen at random and then it is replaced. What? Find the expected number of times a non-red marble is chosen in 531 trials. What? All right, guys. All right. So again, expected number, right? Sorry, let me do this with the highlighter. We're finding an expected number. This, as I told you, is the expected value, right? We know the expected value is the probability of the event times the repetitions, right? So far we need to figure out what is the event and then what are the repetitions. Here, we have the repetitions right there, 531 trials. So this is 531, right? But what is the probability that we're looking for? Well, non-red marble is chosen at random. That is the probability, right? So let me write it here. Probability of, I'm not gonna have enough space. So probability of non-red red. Actually, we can write this better. In mathematics, the not is written like this. That is the not. None equals this. And then not red. Man, I'm using so much proper mathematical notation today. This is not red. So we are finding the probability of choosing a not red marble times the amount of repetitions, right? So 531 trials. Cool. So let's do this. Let's do this probability. All right. Let's do this probability. Look at that. This is how I am splitting the problem into pieces. We'll need to find for the expected value. So we know expected values have this formula. If we know the expected values contains a probability, that is the first thing we're going to find. That is how you solve or approach these type of exercises, little by little. All right, so as a probability, we need to think about the totals, right? The total. So we know 347 are the total amount of marbles. So 347, right? How many of those are not red? Well, we know that we have 125 red marbles. So not red are the rest, right? So 347 minus the one that are red, 125. How many are not red, guys? Anybody? Thank you, Paul. 222. Thank you, Lily. Beautiful, guys. 222. Those are the ones that are not red, right? So we have our success and we have our total. Beautiful. That times 531. Okay, 531. How much is this? Anybody, please, in the chat. This division and then the multiplication. We have 339.7. All right, thank you. Thank you, Paul. This will be the answer, right? Now, Paul, question. Is this the only decimal?
Un uno después de ese 7.
And that's it.
Y un 7.
And that's it.
Y un 5.
Keep them coming.
Y un 7 y un 9.
Paul, give me all the decimals.
Un 7 y un 9 y ya.
7 and 9, right?
Sí, ya.
Cool. Guys, if you are not rounding, you need to write down every single decimal. If you are not rounding, you need to write down every single decimal. All right? What, Paul? What?
Si nada más dejo el primer decimal.
That means you're rounding, Paul. If you leave it up to this point, if this is the answer, then you are rounding.
¿Y está bien?
Remember that expected numbers are not expected to be round.
Ah, carambas.
All right? You only round if the question asks you to round. In this case, the question doesn't say to round, so you need to round. So you need to write every single decimal. Okay? Don't be lazy. I know about these guys. Don't be lazy. And I don't know. Maybe this is something that we mathematicians have caused in you. Because I see a big number like this, and all I'm gonna write is this. I'm being honest. If I look at this big number, I'm just gonna write up to the first decimal point. That's all I'm gonna do. But that is a mistake. So I am guilty of that mistake myself. I need to write every single decimal because that is one of the rules that Math IB has. All right? Beautiful. That is the answer, guys. I think that is it. I want to ask you something, and for that I'm going to switch to Spanish because things are going to get a little bit more complicated. Al inicio les dije, este punto es bien interesante. En realidad, fue facilito. Solo calculamos aquí un expected value, la probabilidad del expected value y luego multiplicamos. Es facilito. A propósito, mira que esto es el contexto, esta parte es el contexto Y aquí, desde el comando, ahí arranca la pregunta, ¿no? ¿Se acuerdan los comandos? Teníamos una lista de comandos. Bueno, si estuviéramos en el colegio, en este momento le estaría apuntando dónde está la lista de comandos colgada y estaríamos buscando qué significa este comando, find. Este comando significa solamente poner el resultado numérico. Entonces, eso es lo que nos está pidiendo. Nos está pidiendo la pregunta un resultado numérico. El resto es contexto. Ok. La pregunta puede ser interesante si hago un solo cambio. Mira, aquí dice unreplaced. Significa que si tomamos una de las bolitas, después de mirar si es roja o no, la regresamos a la bolsa. Digamos que la bolsa está acá. ¿Cierto? Tomamos la bolita, la miramos, apuntamos si es roja o no y luego la regresamos. Hacemos esto 531 veces. ¿Qué pasa si yo dijese aquí que no es reemplazada? Random. Not replacement. Not replacement. Lau Ávila en el chat pregunta, profe, ¿de dónde es que habíamos sacado el 222? Este 222, mira, este 222 de acá, este 2 es la resta. Sí, esto es el no, esos son los éxitos, ¿no? Y el éxito es los que no son rojos. Entonces, pues para calcular los que no son rojos, pues miramos el total menos los que sí son rojos. Mira, aquí dice 347 menos 125. Sí, 125 son rojas, ¿no? Entonces, por eso es que 222 son las que no son rojos. Son de otro color, no sé qué color, pero pues no son rojas. ¿Listo? Gracias, Paul. Muy atento, papá. Muchas gracias. Ok, continuemos. ¿Qué pasa si pongo que no son reemplazadas? O sea, de la bolsita saco una pelotica y la echo a la basura. No la dejo en la bolsita de nuevo. ¿Cómo quedaría entonces el expected value? Esta es una buena pregunta. Esta es una excelente pregunta. Una pregunta de lógica. ¿Alguien tiene una idea? Paul, en términos de probabilidad, muy seguramente negativo. Pero vamos un poco más allá. Lo que yo esperaría es que 125, perdón, 222. Mentiras, espérame. Ya, gracias. Lo que yo esperaría es que me pasen cosas interesantes. A ver, miremosla juntos, ¿listo? Hay 347 bolsas, entonces voy a hacer aquí una bolsita y voy a hacer aquí, voy a notar que hay 347 pelaticas. ¿Listo? Pero luego voy a retirar una para mirar. Voy a hacer esto 537 veces, ¿no? Entonces voy a hacer el primer intento. En el intento 1, en el first try, retiro una pelotica. ¿Ok? Puede que la pelotica sea roja o puede que no. Para eso tenemos nuestra probabilidad, ¿no? Aquí la anotamos. 222 sobre 347. ¿Ok? Vamos a hacer el segundo intento. Second try. Hablemos sobre la probabilidad. Si yo retiro otra pelotica, la probabilidad cambia. Porque ahora no tengo 347 peloticas, ahora tengo 346. ¿Por qué? Pues recuerden que no tenemos replacement. O sea, la pelotica que yo saqué, esta pelotica que acabo de sacar, no la estoy echando a la bolsa. No la estoy echando a la bolsa. O sea que ahora ya no tengo una pelota. La tiré a la basura o no sé, se la regalé al perro, no sé. Pues ya no tengo una pelota. O sea que ahora son 346. En el segundo intento, la probabilidad cambia. Y esto se mantiene porque cuando haga el segundo intento, la pelotica número 2 ya no está. O sea que para el tercer intento ya no son 346, son 345. ¿Sí o no? Cada vez que hago el intento, la probabilidad cambia. Así que este expected value, ¿cuántas son las que yo esperaría que sean rojas? Todas. Todas las 125, perdón, a las que no sean rojas, ¿no? Esa es la que estamos buscando, ¿no? Las que no sean rojas. Pues las 222 espero que sean no rojas. Porque yo puedo tomar la primera, de pronto la primera no es roja, o de pronto sí, no importa. Cuando haga el segundo intento, tampoco importa. Pero cuando haya hecho exactamente, cuando haya hecho, mira, aquí punto suspensivo, listo, punto. Cuando haya hecho estos intentos y llega al intento número 347, al 347avo intento, ¿cuántas son las peloticas que quedan aquí? Aquí hay 0 pelotas. Voy en el 347avo y recuerden que son 347 peloticas. En este momento, ya no me quedan peloticas. Mentiras, me queda una pelotica, eso es un error. Me queda una pelotica. ¿Sí o no? O sea, no sé, la verdad es que no sé si la pelota que está aquí adentro es roja o no es roja, no sé. Pero como ya he sacado el resto, ya tengo el conteo de si son rojas o no. ¿Cuántas he sacado hasta este momento que sean rojas? Pues como ya las saqué todas, pues he sacado exactamente 125 que son rojas. De nuevo, ¿cuántas son las que no son rojas? Como ya las saqué todas, tengo exactamente 222 que no son rojas. El expected value cuando no hay replacement cambia completamente y ahora no se vuelve un problema de cálculo, se vuelve un problema de lógica. Tenemos que ser lógicos, analizar esta situación. En este caso, ¿cuántas esperaría? Pues espero que 222 sean las no rojas. Esa es la que espero. Tiene sentido que aquí el expected value en esta pregunta sea mayor, ¿no? Sean 339 aquí, sea mayor. Pues porque estoy regresando la pelota. Yo puedo hacer 531 trials o puedo hacer muchos más trials. Puedo hacer 1000, 1200. Puedo hacer los que yo quiera. Pero si ponemos que no hay replacement, en realidad el máximo número de intentos que puedo hacer es 347. No puedo hacer más. No es que ya no tengo después más peloticas. En este momento quité la última. No puedo hacer un 348avo intento. No puedo. Por eso quería mostrarles este punto. Menos mal me preguntaron. Este es un excelente punto que podemos hacer muchas cositas acá. Bueno, este es por supuesto cuando hay no replacement, ¿no? Este era un punto facilito. Este era un punto facilito porque nos estaban preguntando con replacement, ¿no? Con replacement. Cuando hay reemplazo, las cosas son mucho más fáciles. Cuando no hay reemplazo, la probabilidad cambia cada vez y bueno, se nos acaban las peloticas, etc. Hasta ahí sería este ejercicio. A ver, déjenme cambio. Aquí. Así. All right, guys. Thank you all for coming. It is 12:30 right now. Hopefully, you guys enjoy this new form of explaining the class, of enjoying the class. Remember, this is going to continue for the rest of the term, right? You guys are going to do the classwork first, and then we're going to do the questions second. All right. If you guys want to include exercises as a part of your classroom, of your class work, you can. Feel free to do that. If you don't, if you just want to read, that's up to you as well. Thank you all for coming. If you guys have any questions, don't hesitate about writing an email and telling me about the questions, right? If you want to have more tutoring, you can do that as well. Write an email and tell me, teacher, please do a tutoring for me. We will see about that. We will put it in the schedule. All right, guys? Thank you all for coming. Hopefully you enjoyed the class. And bye-bye, guys.
Thank you.
Bye.
Ciao, profe.
Bye, guys. Ciao.
Ciao, profe.
Ciao. Thank you for coming, guys. Bye-bye. Ciao, muchachos. Ciao.
Chao, profe,
Vemos, profe.
gracias.
Ciao, Karen. Ciao, Paul.